Hello and welcome to another session on Introduction to Statistics, where we are going to run through a t-test example using the statistical software SPSS. Now, in SPSS, you can certainly make your own data set by inputting everything manually. What we're going to do for convenience and to be more practical, I guess, and realistic, we're going to reference the book Statistics and Data Analysis for Nursing Research, which included a study of 1,000 women in a certain community and did a whole bunch of surveys and collected very detailed information about these individuals. They also provided data files containing the results that we are going to use. Specifically, if you are interested in following along, we use the C file of that survey, of those results that they provide with the book. So here we are in SPSS, and suppose we want to test the hypothesis to see if the employment status of these individuals was related to their level of depression. Now, if you've watched the previous SPSS video in our series, in our playlist, we referenced the depression score. So we will use that variable again. And now we will test the depression score essentially between two groups, those that are employed and those who are not. So our null hypothesis will be that the mean depression score for employed women in this community is the same as the mean depression score for unemployed women. And we'll test that against the research hypothesis that the means are not equal. So in this case, an independent t-test is appropriate, because you cannot be both employed and unemployed. The women being tested in the two groups, they are different individuals. So we're going to go to our SPSS up here and run a t-test. And we'll click on Analyze, Compare Means, Independent Samples t-test. We're going to make that a little bit bigger. The font is still going to be small, but it's a little bit better, and hopefully you can read this. We're going to look for the variable work now. Now this variable is coded to have 0 as the result that a woman was not working, and 1 if they were employed. So we're going to move this not in the grouping. Let's get rid of that. That's not where it goes. It goes in the grouping variable. So we'll click on the arrow moving it, the work now variable, into the grouping variable window. Then we'll click on define groups, and group 1 will be 0 and group 2 will have a code of 1. Now, with the data set, the authors provide a detailed document explaining each variable. So in case this feels a little bit, where do I know all these things? It's part of the book, and it is explained through their book's website. So we'll click on OK. And then we will move the variable for the depression scores, which we saw last time, this CES-D score, to our test variable. We're going to test this variable between the two groups. And then we're going to go to Options and see what confidence interval we want. We'll be okay with a 95% confidence interval. And we'll click on OK or Continue, and then OK, and see what we get. I'm just going to click on this preview print because that allows me to zoom a little bit, making it a little bit, ooh, that's too much zooming, zoom less, making it a little bit easier for you to see, hopefully. But the bottom table here is quite wide, so hopefully you can still see this if your resolution is high enough on your video. So we see here that we had 524 women who were not employed and 436 who were employed. And we see the two means there. We also see the standard deviation numbers are different, which may or may not mean something. And we'll get to that shortly. So in the case for the independent samples t-test, we do have assumptions on equal variances or not, because the formula changes if we can make the assumption that the two groups have equal variances, then a pooled variance is more appropriate in our calculations, in our formulas. So we need to know or have evidence and explore whether we can make that assumption or not. So that is where Levine's test for equal variances comes in, and SPSS does that for me automatically. So let me just see if I can zoom in here. I haven't done that yet, but let's see if we can make this a little bit bigger and then move along the table like that. Then everyone can see it for sure. So the results of Levine's test for equal variances, which tests a null hypothesis that the two variances are equal. We saw that we got, in that case, an F statistic, which is significant at very high significance level, less than 0.001, which means that we can reject the assumption that the variances are equal. Now, we might suspect it when we look at this descriptive statistics here, but that could be well within a random error. It depends. So that could be a part of natural fluctuations within our sample. We really do need a test to know if this evidence is strong enough to suggest that the variances are not equal. And in this case, it is. So then what's nice is that SPSS does both tests for me, and I can choose which one is appropriate. So in this case, a separate variance formula is appropriate because the equal variances cannot be assumed. So this bottom row is where we will find our information to make our conclusion. So the value for T in the appropriate independent samples test is this 6.954 degrees of freedom there. And that was significant at, again, a p-value of less than 0.001. So we'll make the conclusion that the evidence is strong enough to suggest that the depression scores between these two groups of women were in fact, or are in fact, different. So it's a two-tailed test, and our conclusion is that it is in fact different according to this evidence. We can also look at the confidence interval here. We're of course looking at the bottom one, and our 95% confidence interval is between or from 3.64-ish to 6.50. So that means that in repeated sampling, 95% of our samples will have the mean fall within this range. That's of course the difference between the two means. And you see that this does not include 0. And so that agrees, or that matches the conclusion of our hypothesis test. There's an alternative way of doing it, that we reject the assumption that these two groups have the same depression scores, or on average, the same mean depression scores. So again, let's just run through the buttons that we click for our independent samples t-test. We'll click on Analyze at the top, Compare Means. Oops, there we go. Independent samples t-test. And then the variable that we test and across which grouping variable we test. In our example, we tested the depression scores and we tested them for two groups, those that are unemployed and those that are employed. All right. So that hopefully gives you an idea of how SPSS can be used and where to look for the information and make your conclusions in your hypothesis test. This is part of our ongoing series as our introduction to statistics. So feel free to watch the other videos and let me know if you have any questions.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.